From the title and thumbnail, you may have guessed the content of this video. Okay, so in this video, I will be talking about 3 fractals and will show how to code them. Starting with Spirograph Fractals. Before talking about Spirograph Fractals, let's take a look at Spirograph first. Some of you might have played with Spirograph in your childhood. These are rolling circles toy which produces beautiful curves. In order to understand and able to produce these geometrical curves, we need to understand mathematics behind it, which is nothing more than an elementary maths. Consider these two tangent circles of radius capital R and small r. Our aim is to trace this point P. Let smaller circle rolls clockwise about its center without slipping. After few instances, let center of smaller circle covered theta angular distance and point P covered alpha angular distance measured from horizontal. In order to incorporate no slipping condition, the distance covered in both circles must be equal, which are capital R times theta and small r times gamma respectively. Equating these, we get relation between theta and gamma. From geometry, we see gamma plus alpha minus theta makes a full circle. Using this relation, we obtain a relation between theta and alpha, and that's what we need. Now to get coordinates of point P, we use change of frames theorem, which is coordinates of P with respect to origin is coordinate of smaller circle with respect to origin plus coordinates of P with respect to center of smaller circle. Hence, x coordinate of P is x coordinate of smaller circle, that is capital R minus small r times cos theta, plus x coordinate of P with respect to center of smaller circle, which is nothing but small r times cos alpha. And in similar fashion, we will get the y coordinate. Now we have all required coordinates. We can jump to coding. I will show only crux of codes, not complete code. However, you can find all code files in description. For coding, I will use graphics library of Python. I am going to fix capital R as 1 unit and will vary small r and f. Here f denotes how far point P is from center of a smaller circle. Let's draw our circles. At each iteration, code will update desired coordinates according to equations we obtained before. Let's execute this code. One can play with various combinations of R and F. Even one can also incorporate more than 2 circles, some inscribing, some circumscribing other circles. Amongst plenty of combinations, many results in a fractal. I will be showing one of them. Consider this configuration. Here are 6-7 circles that are tangent to previous circle from outer boundary. Each consecutive circle is twice smaller and rolling twice faster than previous one, and the direction of omega is alternate. To get coordinate of P, we will use same change of frame and the same equation that is used before. At the end, it will result in a recursion relation. Let's trace point P to get a spirograph fractal. The next one is Curlicue Fractal. We get this using iterators. Take an irrational number and start with a unit length horizontal line. In next iteration, we draw next line making phi n plus 1 angle with the previous one and repeat this process. To get phi n plus 1, we use phi n plus 1 equals to theta n plus phi n modulo 2 pi. Where theta n is itself an iterator, that is theta n plus 1 equals to theta n plus 2 pi s. This s is our irrational number. Modulo 2 pi. Here theta 0 and phi 0 both are 0. Coding this is very simple. Start with an irrational number and initial theta and phi. At each iteration, update theta and phi according to rule. Get new coordinates according to updated phi and draw a new line accordingly. Let's look this fractal for different irrational numbers.